How are you all? I am Diego Didicus, Maths faculty of Sacred Heart Central School. In this video, we will be discussing about Mathematics Class 10, Chapter 10, Circles. As we know, circle is a collection of points equidistant from its center. And we know the parts of the circle. We have circumference, radius, diameter, chord, sectors, minor sector, major sector, arc, and so on. For class 10, we need to know about the three parts. We need to know about chord, secant, and tangent. Considering a circle, if a line touches the two extreme points of a circle, it is called as a chord. A line segment which touches two extreme points of a circle is called as chord. A line which cuts a circle at 2 points is called as a secant. A line which cuts the circle at 2 points is called as a secant. So there is a difference between chord and secant. Chord is a line segment which touches two extreme points of the circle, whereas a secant is a line which cuts a circle at 2 points. Now talking about tangent, that is the most important word in this chapter. We will be discussing about tangent throughout this chapter. So tangent is a line which touches the circle only at one point, which means a tangent will lie outside the circle and it will touch or intersect the circle only at one point, whereas chord and secant touches or cuts the circle at 2 points. Talking about tangent, it is a line which touches only at one point of the circle. The word tangent comes from the Greek word tanger, which means to touch. It was introduced by a Danish mathematician named Thomas Finnick. Also, there is a comparison between the secant and the tangent. If you look closely, tangent touches the circle only at one point, whereas a secant cuts the circle at 2 points. So I can say that tangent is also a secant when the 2 points of the secant coincides at one point. Can you understand this? A tangent is a special case of secant when the 2 points of the secant coincides at one point. And now there is a question for you. Just think and answer, how many tangents can be drawn on a circle? A tangent is a line which touches the circle at one point. And now my question is, how many tangents can be drawn on a circle? Let's check. Now I'm going to consider this point. And on this point, I'm going to draw a tangent, which means it touches the circle only at that point. If I consider this point, here also I can draw a tangent. Likewise, each and every point of the circle, I can draw tangents. So we can conclude that on a circle, there are infinitely many number of points, and in those points, we can draw infinite number of tangents. So it is not that a circle will have only one tangent. A circle can have infinite number of tangents. Do you understand? Each and every point of the circle, a tangent can be drawn. Again, a tangent is a line which touches the circle only at one point. A circle is having infinite number of points equidistant from the center. So in all those points, I can draw a tangent. Now, I am going to draw parallel lines intersecting the circle. Let's see what can we conclude from that. Again, I am going to consider a circle, and in this circle, I am going to draw parallel lines intersecting the circles. So from this diagram, what can we conclude or what do we observe from this diagram? Through this diagram, I can conclude that at the most, two parallel tangents can be drawn on a circle. Look here, this is a tangent which touches the circle at this point, and when I draw parallel lines which is intersecting the circles, I see that there are only two tangents parallel to each other to a circle. So you need to understand a circle at the most it can have only two parallel tangents at a moment. Now let us discuss about the theorem 10.1 from this chapter. The theorem says that tangent at any point of the circle is perpendicular to the radius through the point of contact. Now let us try to understand what the statement is. Tangent at any point of the circle is perpendicular to the radius through the point of contact. Okay. I'm going to draw a circle here, and as we know, a circle can have an infinite number of tangents. So I'm going to draw one tangent, name it as A, B, and let this point be P, which is the point of contact. Point of contact is nothing but the point where the tangent touches the circle. Now from the center, I am going to draw lines which will touch the tangent AB. So there are a number of lines which is touching the tangent AB. From this diagram, I can see that the length of the line, naming it as O, C, D, E, F, G. I can see that the length of OC is longer to the length OP, and OD is also longer to the length OP. I can conclude that the line OP, which is the radius, is perpendicular to the tangent AB. That is what the theorem says. Tangent at any point of a circle is perpendicular to the radius through the point of contact. So only at the point of contact, the tangent will be perpendicular to the radius, not any other line. It is perpendicular only to the radius and exactly at the point of contact. That is what the theorem 10.1 says. Okay? Tangent at any point of the circle. It may be any point. This tangent can be at any point of the circle. But it will be perpendicular to the radius at the point of contact. So, in other words, I can say radius is perpendicular to the tangent at the point of contact. Here, OP is the radius of the circle. I said radius is perpendicular to the tangent at the point of contact. So, with this information, let us try to solve the exercise 10.1. Now, let us discuss about exercise 10.1 from this chapter. The first question. How many tangents can a circle have? As discussed before, a circle can have infinite number of tangents. Question number 2. Fill in the blanks. A tangent to a circle intersects it in dash points. So we know that a tangent touches the circle at one point. So the answer for this question is 1. A line intersecting a circle in 2 points is called as dash. Okay. So talking about tangent, it touches the circle at 1 point. If a line intersects a circle at 2 points, it is called as? Yes, it is called as secant. A secant is a line which intersects or cuts a circle at 2 points. What about chord? Chord is a line segment which touches two extreme points of a circle. Question number 3. A tangent PQ at a point P of a circle of radius 5 cm meets a line through the center O at a point Q, so that OQ is 12 centimeter, length of PQ is. Now let's draw the diagram for this question. The radius of the circle is 5 centimeter and a tangent PQ is meeting the circle at the point P. So the radius O, point of contact P, and the tangent PQ. The distance of OP is 5 centimeter because that is the radius, and PQ is the tangent to this circle meeting at point P. Now the distance of OQ, 12 centimeter. Find the length of PQ. By applying theorem 10.1, I can say that radius is perpendicular to the tangent at the point of contact. OP is perpendicular to PQ at the point of contact with the help of theorem 10.1. From here, I can say that OPQ, angle OPQ is equal to 90 degree. Now considering the triangle OPQ, I can say that triangle OPQ is a right angle triangle. Triangle OPQ is a right angle triangle. From here, by using Pythagoras theorem can be applied in right angle triangles. Pythagoras theorem says that the square of the longer side will be equal to the sum of the squares of the two smaller sides. So here the longer side is OQ. Square of the longer side will be equal to the sum of the squares of the two smaller sides. Substituting the known values, OQ is 12, so 12 square is equal to OP is 5 square plus PQ square. Now 12 square is 144, which is equal to 25 5 square plus PQ square. Now PQ square is equal to 144 minus 25. PQ is equal to root 119. So the answer for this question is option D, root 119 centimeter. Question number 4. Draw a circle and two lines parallel to a given line such that one is a tangent and other a secant to the circle. If I consider this as the given line, I am going to draw a circle and I am going to draw two lines parallel to the given line such that one is a tangent. I know a tangent, it is a line outside the circle touching the circle at only one point. Then a secant. If this is the center, I am going to draw a secant, which is a line parallel to the given line, but it touches the circle at 2 points. So this is the secant, this is the tangent, and this is the given line OA. So in the next class, we will discuss about exercise 10.2. Thank you.